peeps. I need to like make these more entertaining, my intros at least. So, because I feel like I've done a good job in making everyone cringe in the first videos that I made, so I'm kind of lacking on these recent videos, so I gotta say some cringy stuff in the beginning. So yeah. Anyways, today we are going to be going over the first law of thermodynamics. So much fun. The most funny thing about this is that I actually didn't learn this until I took Physics 2 at college at RCBC. So I literally didn't learn how to do this until last semester. But now I've like kind of, I guess, like mastered it, and I've learned like a lot more to then like just this stuff. But I'm telling you, I sat in that class and I was like, what is my professor talking about? He's like, you learned this in Gen Chem. Fun fact, I didn't take Gen Chem before I took this class. So I was like, what are you talking about? So it can be a little bit difficult to understand and get down. It takes a lot of practice. But I'm hoping that I can kind of like help you guys through this video and like through some explanations, because it's really all about visualization here. But yeah, so the calculations for this fairly easy, like basic like pre-algebra, you know, finding the term you need or whatever. I don't know how you would explain that. But the basic equation for this is that E, or change in E, is equal to Q plus W, right? So what change in E is that's the change in energy. So the change in energy in a system. That's all you really need to know about that. And then Q is the heat added to a system, and work, or W, is the work in a system. Work added, work removed, work done. Usually you call it like the work done in a system. But let's take a look at how that works and looks in a system. So I put a note here that change in E, Q, and W can all be negative. Just because they're written out positively in this equation doesn't mean that they're going to be positive when you do the equations. You have to find out when it's going to be negative, when it's going to be positive, and vice versa. So let's look at this system here. You can think of this system as a chemical reaction. You can think of it even as like a refrigerator. That's one that is like, it sounds so stupid, but I think of it as a refrigerator. I don't know why. But you're just thinking of a system. So like something, you can think of it, something inside of a box. You have something going on inside of a box, and we're trying to figure out how much energy is in there, how much heat is added, how much work is done in that box. And the surroundings, you can think of that as like the air around the box, or even you know, the person who's feeling what's happening inside of the box. So we'll just take this as thinking of the box. If you want to think of it as a chemical reaction, if you want to think of it as something else, go for it. But inside of this box, we have the system. When heat is removed from the system, so let's say that the system removes 10 joules of heat, right? Because heat is in joules. It's going to be a negative Q. So heat is leaving the system. It's saying, bye, like, I got places to be. I'm leaving. Don't want to be here anymore. So the system loses heat. So it's going to be a negative Q. The opposite happens when Q is being added to the system. So the system's like, dang, like, I need some heat right now to do this reaction. Whatever I need some heat. I'm cold. I need to warm up and do this chemical reaction. Heat is going to be added from the surroundings. So heat is going into the system, therefore the system is gaining heat, so the Q is positive. Again, heat leaving the system, going away, leaving the system becomes colder, or the system just loses heat. Negative Q, heat going in is going to be a positive Q. So now let's look at work. Same exact situation. If work is leaving the system, it's going to be negative work. So what that means is that the system is doing work on the surroundings, right? We usually kind of think of this as like a volume change. So if work is being done onto the surroundings is like being directly affected by that work. Whether it be like some molecules are moving or things are getting smushed together, whatever you can think of, or whatever you want to think of, the system is doing work. So it's physically doing something to change the surroundings. It's kind of what like work you can think of, I guess, in this scenario, right? So the system is the system is doing work on the surroundings, therefore work is leaving the system. And it's going off to do other stuff on the surroundings, right? It's like, you know what? I'm not feeling like being in here. I'm gonna go mess with the surroundings and, you know, have some fun with some particles out there. So I'm gonna go do some work over there. Work is leaving the system and doing work on the surroundings, so it's negative. Opposite, as if the surroundings are doing work on the system, right? So if you are, say you have the system trapped in a vacuum, and you are, I guess, you could say adding pressure into the system. So if you're adding a bunch of pressure into the system, the surroundings, so the air particles are doing work on the system. Sometimes it'll be so strong to even crush the system. Like if we're thinking of it as a box, work is being done to crush the box because the pressure builds up and it crushes, right? Or, yeah, so like that's a way of thinking of it. So the surroundings are doing work on the system. Similar thing to the heat, the work is going to be positive, so it's going inside of it. I have that kind of written down here. So work done on the system is positive, work done on the surroundings is negative. Heat released from the system is going to be negative Q, and heat added to a system is going to be positive Q. I actually like to draw this out every single time I do these problems because it is hard to visualize, but if you can draw it out and kind of be like, okay, so work is leaving, so it's going to be negative. Q is leaving, so it's going to be negative. Q is going in, it's going to be positive. W is going in, it's going to be positive. It might make it a little bit easier. So let's get into some practice problems here. So this was one that Professor Sherlock had in class. It says that what is the change in energy in a system when it releases 100 kilojoules and has 100 joules of work done on it? All right, so let's visualize this first. So we have the system and we have the surroundings. So it releases 100 kilojoules. So it's releasing that as heat. So it's going to be like this. So Q is going to be positive, and this is Q. And it has 100 joules of work done on it. Oh, well, Q's not going to be positive, I'm sorry. Q's going to be negative. So releases it, therefore it's leaving, so it's going to be negative. It's leaving the system. Again, this is Q. And it has 100 joules of work done on it. So work being done on it, that is going to be positive W. So Q's going to be negative, W is going to be positive, but we also have to do a little bit of dimensional analysis, a conversion. Is that the conversion? Guys. Anyways, so we have 100 joules and we want to get to kilojoules. There's 1,000 joules in 1 kilojoule. And I'm just going to do the math there. Well, I don't need to do the math because it's a pretty simple one there, but you can do it in your calculator. But that's going to be the amount of work done, 0.1 kilojoules. All right, so now let's move on to doing the first law of thermodynamics equation, Q plus W. All right, so we're looking for the change in energy, so we don't have to move anything around, so that's awesome. So the Q that we're given, again, is going to be negative, so we're going to make this negative. Again, it's not going to tell you if it's negative or positive. You, most of the time, have to figure that out. So it's just going to say it releases it. That's just the quantity. We have to find if it's going to be positive or negative, right? So we're going to make this negative, 100 kilojoules, plus the positive, so we're going to keep that as a plus, positive 0.1 kilojoules. And our answer is going to be negative 99.9 kilojoules as the change in energy. Let me just check my answer and see if it's the same that we got from class, and it is. So cool. Awesome. All right, so now we're going to do this other practice problem. As I like to do, you guys can pause the video and try this out yourself, but I will be going on to do this. I think it's definitely good for you guys to try them out on your own, just because you have to do it on your own during the test. So if you guys feel confident, go for it. If not, do some practice problems after this in the textbook. Practice makes perfect, honestly, when it comes to a class like this. Okay, so calculate the work and determine if it was done on or by the system if 982 kilojoules are released and the energy is negative, negative 1.4 times 10 to the third kilojoules. I'm not even kidding. When I'm reading out a problem, like if the system does blah, 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 released and blah, 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 and then I start doing the math, like I don't actually read it out in my head. I just go blah, 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 and then blah, blah, blah. It's my way of test taking. So let's again draw a little bit of a diagram. So here's our system. So we don't know the work, so that's what we're going to determine, and we're going to add that in there to like help us determine that. So the system, and we have 928 kilojoules is being released, so it's going to be a positive Q. And again, this is going to be Q. So how we can determine that this is Q is because it's being released or added. So if we see the words released or added, it's going to be Q. And also we can just kind of do process of elimination, right? So we have E, cool, we don't have to worry about E anymore. And it's asking for work, so this has to be Q. So let's get to doing our problems, because this is in kilojoules and that is in kilojoules, so we don't have to do any conversions there. Okay, cool. So energy, we can just put that right in as negative 1.47 times 10 to the third kilojoules. That's going to be equal to negative Q because it's being released. Again, oh my god, I keep saying that's positive, guys. It needs to be negative. I always draw out wrong, but no, this needs to be a negative Q. Apologies for that, because it's being released. So we have negative 928 kilojoules plus the work. And again, we're just going to have to add this over. I guess I'll like draw that out. Kilojoules plus 928 kilojoules. All right, do that on my calculator. 1470 plus 928. And the work should be negative 542 kilojoules. I'm going to actually check the textbook and see if that's an answer. What did I get? 542? That's real awkward because it's not an answer here. Oh, yeah, that could be that answer there. Yeah, okay. Cool. So that is one of the options there. Right, that's times 10 to the 2. Okay, cool. So yeah, that is our answer for the work, and it also asked us to determine if that is work being done by or on the system. So when work is negative, it's released, right? So work is leaving, it's doing work on the surroundings. So that means that the system is doing work, right? So the system itself is doing work. Work is not being done on it. It itself is releasing work, and it's doing work on the surroundings. So work is done by the system. So that would be our answer there, and then we'll check here, see if that matches up. Work done by the system, and that's what we said. So that would be your answer there. Same thing as always, thank you guys for watching this, and good luck. Don't forget to ask questions. Thank you all.